Good morning, everyone. We're a little bit early. We're going to start at about 10:01, 10:02. But as you're there early waiting, if you could read this simple update, if you would like to ask questions during this next live event, um, you have to open up the question pane, and some people couldn't find that. So there's a little question mark icon on the upper right. And once you click that, you have the ability to ask questions during the seminar. And we ask that in the area of where you ask the question, there's a little section that says you or anonymous. We would ask you to click on that and change it to your name, and it'll just help us know who's asking the question. Thank you. Give us a couple minutes here and we'll get started. Good morning, everyone. We're still a little bit early. We'll start in a minute or two. Just wanted to remind you that if you would like to ask questions during today's live seminar, there's a questions button on the upper right of the screen. It's a little question mark icon. If you open that up, it'll open up a questions pane. And so at that point, you can ask questions. So please be patient and we'll start in a minute. Good morning, everyone. Welcome to Maribeni Citizen-Cincom's live web event. Today's web event is a virtual demonstration on our Citizen-Cincom L12, and exciting news that we've now added the laser to the L12 series. We're going to learn more about the MCC Laser updates and the L12, and our regional manager for the New England office, Mark Carlson, will be giving this presentation today. And Mark, your nice new background and you are now live. So please start.
Okay, thank you, Brian. Well, welcome to today's presentation, the Citizen-Cincom L12 Type 7 with the laser review. Again, as Brian has said, I'm Mark Carlson and I'm the regional manager in the South Central area. But thank you again for joining us. I want to start today by taking a look at the L12 and some of its key features. Towards the end of this presentation, I want to invite Randy Nickerson to answer some questions. So we'll have a whole section just on the laser and a chance to ask your questions with Randy directly. He is the head of our laser group, and again, that will be towards the end of our presentation. Some of the L12 key features. We have the ability to switch between a guide bushing type and a non-guide bushing type machine. And it takes about 30 minutes. So now in the picture you see in front of you, you see the main picture, which is showing the L12 in guide bushing mode. And then in the lower left corner, you see it in the non-guide bushing layout. What that means is that the headstock has a sleeve on it, the guide bushing is removed, and the spindle works directly next to the gang tools, allowing us for shorter remnants, especially with materials that are to make it more cost effective. Some of our other features, we have high-speed spindle and rotary tools. So now our main spindle, once it's in the guide bushing mode, that allows us to run about maximum 15,000 RPM. When we run in non-guide bushing mode, it drops down to 12,000 RPM. Its motor is rated for about 2.2 to 3.7 kilowatts, depending on torque and all that. Our rotary tools on the gang have a max spindle speed of 10,000 RPM, and it's rated for 0.75 kilowatts. Now looking at our back spindle, that has a 10,000 RPM maximum and up to a 0.75 kilowatt rating. On this L12, we have the back rotary live tooling, and they have a max spindle speed of 9,000 RPM and rated about 0.5 kilowatts. Another key feature we have is on the front of our L12, we have a wide operator access door. The nice thing about this is having this full front door that moves up and out of the way makes working in the machining area much easier. Some other key features, the NC program input and output. We have USB, compact flash, RS-232, and Ethernet. And I must add that this machine supports all 4 I/O formats as standard. So you get all 4 of them. You don't have to have an option for either of the 4. Now in the standard machine, we can fit up to 28 tools. Gang, cross rotary, front and back, ID work is shown here. You have a location next to the sub spindle, which we'll talk about later, and then live or static backworking tools. Two optional tools I'd like to talk about is we have the GSE 3607, which is 3-face, 3-front, live. And they can be set at an angle. So this will make things, easier for the, cross-side angled holes. And on the back side, we have the GSS 1530. Now this can be used for saw slotting and other features on the live backwork block. Now, an additional thing not shown here is we have the CSM4. They are cross live straight spindles, which are capable of reaching 24,000 RPM. Again, it's worth mentioning that the first live tool position, T7, which is located right next to the gang, is a non-removable station. It is ER8, but it only has a shift of 5 millimeter. The remaining removable spindles are ER11 with a 10 millimeter shift from the face of the guide bushing. So T7 allows us for the ability to use smaller tooling closer to the guide bushing. As I almost mentioned earlier, deep hole drilling. Again, as you see there on the side of this L12 subspindle or back spindle, we have the ability to do standard or deep hole drilling. From the face of the block to the face of the guide bushing is approximately 91 millimeter or 3.582 inches. So yes, this can be used for deep hole drilling, but it can also be used for standard drilling as well. Now our optional LFV function is for effective machining or difficult to cut materials. LFV, for those that don't know, is a low frequency vibration cutting. It is a technology for performing machining while vibrating the X and Z servo axes in the cutting direction in sync with the rotation of the spindle. As shown on the side here, it can break the chips effectively, removing some of the many problems. It is also effective for small diameter deep hole machining and the machining of difficult to cut materials. For LFV machining with rotary tools, the LFV function and the rotary tool feed per revolution options are required. We have the availability of 3 modes that can be used on ID, OD machining, as well as threading. So for more information on this, please speak to your local dealer or any MCC representative, and we'll be more than happy to provide you with some more information on this. We have the user-friendly screens, and it's been designed from the operator's perspective. This L12 Type 7 is equipped with a high-speed NC. We have on-machine program check function and easy-to-understand illustrations. On our machine check, this can help you with proving out a new program or just checking a new addition to that program, whether it's just running through the program with no machine movement or using the handle to actually move through the program as if we were machining. Also, having a visual representation, it can help everyone, including those new to the Cincom machines. So when you're looking at the control, you're looking at a feature, and it has a highlighted picture. It shows you exactly what you're dealing with, whether it's a tool, what tools are in the machine, and a lot of other great features. Some other of the features we have a codeless display. So now our code list not only displays codes and arguments that go along with that code, but the codes can be inserted directly into your program from this page. So instead of having to go back and forth, you can enter in this code, enter in the arguments, and then just insert it into your program. Now our eco screens can provide information for those who need to monitor power or the consumptions and any other information. Laser cutting and welding. Now we've talked about the L12, and now we reach the laser portion of this presentation. And we will be looking at the L2000 series laser system. Just a quick note on these systems, that they are retrofittable on a variety of our machines, not just the L12. We've developed this as an add-on, an option that can be attached not only to new machines, but certain older generations of our L series machines. We've also looked at this and designed it to have as little effect on the machine's capability as possible. Here are some pictures of that show the laser head mounted on an L12. Please be aware that when the laser head is mounted, it's mounted in the gang, and we will lose the end work arm, which will have to be removed, and we lose the ability to use one crosswork live station.
Yeah, and this restrictions on the L12. For example, the L20 is different, and so this is specific to the L12.
Correct. And depending on which machine the laser head is mounted on in the application, of course, with the other machines, you have the availability of B-axis and so many other awesome things that you can do with the laser. But in this case, we're just focusing on the L12 Type 7. Now, here's a drawing to give you a representation as if you were looking at the laser head from the sub spindle. And it gives you an idea of where it fits in the cabinet, how it fits on the gang, and it just gives a good visual representation. Now, let's talk about some of the traditional components of our laser systems, or any laser system, for fact. What is needed for a laser function is a light source, or laser oscillator, sending the beam through the fiber optic cable, which here is your transfer line, to the head, or our laser processing head. Here it is joined by a flow of gas, which here would be our assist gas, and passes through a nozzle to the material, or our part, where cutting or welding will be done. The gases that we currently use are oxygen, nitrogen, and argon. Here we see some of the components of our Laser 2000 system. Again, these are the main components. Our Laser 2000 system consists of the control cabinet, which holds the laser, the gas control, and our communication systems, along with the power supply panel. The Gen 2 system will also contain the CPU for our laser computer. The laser, which is in our control cabinet, has a fiber cable permanently fused to it. The touchscreen PC, this holds the software that contains the recipes used by the laser during cutting and welding. Now, this laser, or the touchscreen PC, is actually mounted at the machine near the control, so for easy viewing and access. Some other components in the picture shows the laser head and our optics cleaning kit. The laser head is located inside the machine as we show it on the gang. And another thing to mention is that our original machine window gets replaced with an acrylic laser protection, which is RoHS compliant and complies with ANSI Z136.1. So this way, you don't need to have your glasses on when the door is shut. Now, okay, you might want to ask, why would we want to offer this capability on a Swiss machine? We have many customers that are doing laser cutting or welding on a secondary machine, which of course is very expensive. We know that any secondary operation that is required adds cost to this part and more quality risks. Just like the twin spindles of our machine save time and money, so too will the addition of the laser into our machines. Now we have the ability to add a laser onto our lathes, but they cannot add a lathe to their laser machines. Now we're going to talk about some of the benefits. Benefits of laser machining. So now, near endless geometric shape possibilities. Minimal burrs, or also known as draws. Faster than EDM machining. Now, the benefits of laser machining on a Citizen machine. Conventional and laser machining done in a single machine. Machine accuracies 2.0001 inch or millions. An auto loading system which can handle material lengths up to 12 feet. So that means we can also utilize standard length tubing. Complete multiple operations in a single setup. Now, if you need to do prototyping and you don't have tubing to create your part, we can create tubing from solid stock for prototype work. Now, again, reduced handling, improved process control, and increased throughput. We are really in the realm of we are only limited by our imagination and what we can fit into the machine when we start adding the laser to this. Shapes, anything, there are virtually so many combinations of things that we can do on this. I couldn't even list them all. Now, going back a little bit to a typical simple laser, the part requires tubing to be cut and finished to a finished length, then cleaned for loading into a dedicated laser machine for the laser cutting to be done. Now, with a lead angle like the part above, they would need a turning or grinding machine operation. Then, depending on the laser cutting result, it may need handy burring and or descaling, also known as pickling or pickling. Our advantage lies in the ability to do recutting with tools, drills, boring bars, reamers, or even using brushes to clean up our part. Our goal, complete parts in a single setup. Now, I know we're going to be talking with Randy later, but some of the things that are frequently asked are, what thicknesses can a laser cut through? Well, this is going to depend on the material and which power laser level laser was ordered. So, as an example, we have up to 125 thousandths in stainless steel with a 300 watt QCW unit. And for specific situation information, please consult our laser department. Now, what is the width of the laser cut? This also depends on which laser unit and focal distance used, but it can be down to 0.0005 or 5/10. The thickness of the cut and power required can affect this. So again, more power will equal more melt away. What is the lead time for laser systems? Well, we have them in stock, waiting for a machine to install them upon. Once we have the machine at MCC New England, we can install a test laser in approximately 3 days. Some of our machining examples. In the pictures below, you're going to see the following examples that can be obtained with laser cutting. So slots, holes, and special features all can be laser cut. This next picture shows an example at 7.5x magnification. And it shows an array of features in a single part. So not only have slots, holes, intersections, but all these features and at a very small size. Here we have an array of 10,000 diameter holes at 25x. So, and the time it would take to do this with a drill, I mean, the laser can simply just do this effortlessly. Small complex features can be attained by using the laser. Again, looking at this part and this feature, we're at a 30x magnification. The length on this, it's 6,000. And this feature wouldn't be allowed, with a traditional machining. Now here we're going to show some examples of laser cut times. Now we have windows in the top left. There's 4 of them, and the shooting side time is about 12 seconds. There's a spiral cut feature underneath that, which has a feed of 2.0, and that's about 13 seconds. Now we have a stent. This contains 36 diamonds, and that's done in 50 seconds. To our upper right, we have a J slot. Now that was done in 7.68 seconds. This next thing is 5,000 and 10,000 hole arrays. Now again, it took 235 seconds or 236 seconds, but there are 360 holes in this feature. Now our stent on here is 72 diamonds, so that's 92 seconds. It's a tighter pattern and it contains more cuts. Something as simple as a bone cutter, a little over 6 seconds. Laser welding. So not only are we talking about laser cutting, but we can use the mechanic collar system for accuracy, because the runout on the part in the picture below needed to be less than 1 thou 5/10 after weld. And this is doing it with the same laser, so it's not like you need 2 different lasers, one for cutting and one for welding. They both can be done with the same one. Now, the next part, we're going to talk about focal length of our laser objects. On the L12, we use a 75 millimeter focal length. Now, focal length is changed by the focus lens and the nose piece. Okay, at this time, let's take a quick peek under the hood of our laser head. So now, at the top, we can see our focus adjustment screw. This is all manual adjustment. We also have 2 nozzle adjustment screws, one on each side. Those are both contained in our focus lens housing. Now, we have the unit down below, and then we have our nozzle retaining nut that's mounted to the cover lens housing. Another thing to talk about, beam delivery. The beam travels through the fiber cable and passes through a collimating lens, that captures it and shapes it into an even column. Then it is directed at a deflection mirror, which points that towards another focusing lens. That takes the column and directs it to a point, divergence of the beam. This point is our sharp focus, or cutting diameter, which will provide us with the cutting or welding action. At the 75mm lens, you're looking at a 10.66 micron spot size. Okay, let's talk a little bit of our laser controlling software. That's called the IPG Link. This is where the cutting parameters are entered and stored. The new Gen 2 IPG Link screen, which we show here, all of these are sent from the machine program. So it's not like you have to put them somewhere else. You can send them with each program to the software, and then they are displayed here on your PC screen. Now there are some settings that are needed here. And these are our frequently changed settings with their description. Okay, so we got your mode, continuous wave, pulse, or quasi-continuous, if available, depending on the laser head. We also change our pulse width. That's the length or the size of the beam shots. We have rates hertz, our frequency. How many pulse widths per millisecond? Power. Okay, this is the percent of the laser unit to be used. Gas types, we have inert or oxygen. Gas PSI. This shows our purge air PSI. Inert, of course, that shows the inert gas PSI. Oxygen will show the oxygen PSI. And then for description, optional text can be used here to describe whatever is going on. Now, here's a sample of the program code for the IPG Link for Gen 2. Now, we have, of course, to activate the RS-232 communications, P open. Use the D print to shut off emissions. The following code will show you to set the focus position. So this physically moves the focus lens. On our next line, our D print QCW on, that will set the QCW mode to on, of course. Our next line will set the gas type and the PSI needed. Look at our next line. We're setting the mode, the pulse width, the frequency, and the power. Then we can turn our emissions on and activate the settings. Then, of course, we deactivate the RS-232 communications, and we can go on to doing what we need to do. Now, to cancel these settings, again, we have to activate our RS-232 communications, deprint all off, which will cancel all the settings, and then P-close to deactivate the RS-232 communications. Now, we do have M codes to turn the beam on and off. M260 will turn our beam on, and M261 turn our beam off. And again, this is all done from inside our program. Now, let's take a look at the advantage of the Laser System 2000, L2000. We have the IPG Photonics. They're a leading provider of fiber lasers in the world. Okay. The laser is 100% supported in the USA. It's air-cooled. We have a 400-watt output power. Other selections available up to 3 kilowatt pulse. We have a 10 micron delivery fiber. Again, this will be determined by your unit choice. an internal pulse generator with endless parameter possibilities. Now we're going to take a look at some of the benefits of our laser optical head and its specifications. We have a CCD integrated camera for optical viewing and alignment. We have the fine XY beam adjustment for beam alignment to the nozzle. We have 75 to 100 millimeter focal lengths available. And on the L12, I must note that we keep that to the 75 millimeter. A head assembly is completely liquid tight. The head is also 100% made and supported in the USA. And we can achieve kerf widths down to 20 microns.
Just a quick statement, I haven't done it all the time, but I set up a laser, and that camera is just wonderful to find your center and the center of the gas. It's just wonderful.
Now, okay, with that, we're going to talk about some of the advantages of the Gen 2 laser, new features. Now, with the Gen 2, it's fully programmed and controlled from within the Cincom part program. And so are the following: programmable focus adjustment, the programmable gas pressure, and programmable air pressure. And again, they all come from the Citizen-Cincom part program. Now, the assist gas, we have 3 supply lines. So 3 tanks or 3 types connected at one time. And chosen through our program, we can have 2 internal to the head and 1 external. Another thing to add is an AC unit within the control cabinet for temperature control. Now at this time, I'd like to introduce Randy Nickerson, the person behind our laser program, to answer some of your laser questions, and you have an opportunity to talk with the man. So, Brian, if you could, please.
At this time, there's actually 0 questions, so we can say it could be a 15-second delay. So if anybody has any questions, could you please post them now? So as we're requesting any questions or any comments, do you have the laser video ready to play, maybe?
Unfortunately, that I do not, Brian.
Okay. Randy, you can probably whip that out quick?
I believe so.
So if you just give me your screen, share your screen.
1 second.
Mark, you did so great, they don't even have a question.
Or they all ran away.
No, we got over 80 people there. Here's a good question. What materials are not good with laser use?
The laser likes harder materials more than soft materials. So our laser is not going to cut plastic. If you get into brass, bronze, aluminum, it can cut it. It just takes more power to cut softer material than harder material. A little different than our turning.
Okay. We do have another is, are there plans to implement the L2000 on the A20?
Yes, we are in process now of developing that, then get the paperwork all done, and that'll be available. But it definitely can be put on the A20.
So currently it's the L series and A20, and we have done Miano GTY.
Correct.
And then another, I think you already covered it, but you can say it again. What are the inert gases?
The inert is non-flammable gases, which is the argon and the nitrogen.
Yeah, that's just a gas that helps assist the temperature rise and assist the laser cutting.
Correct. Well, when we use oxygen, it adds to the ability of the laser. The laser can cut faster through thicker material, but it does leave a little bit of discoloration, which comes off quickly in a pickling type operation to clean it up, to make it look, bring it back to normal coloration.
Here's a good question. Is it possible to manually change the laser angle on an L20 type 7, which I think more so an 8, or type 10 machine? So can we mount the laser as a cross, but can we manually adjust it for some special part?
The bracket, the standard bracket that we make is made to hold it in the 90-degree location. We could make a special bracket to allow you to adjust it, to move it around a bit. The problem with that is if you bring the angle out too far, you can't move it out of the way when the subspindle needs to come in to pick the part off. So it could create more collision concerns. Whereas the type 12 with the B axis, we can program the laser to move out of the way so we don't have to worry about it.
So we haven't done that yet. You could for a little, but probably if you were going to do parts like that, we would recommend a type 12 with a B axis.
Yes.
Why do the same settings work on one machine with the same material, but not work on the second machine with the same material? Sounds like somebody has information.
Well, all I would say is if the settings that were successful on one machine are not working on a second, the focus must be different, or the power unit might be different. We offer different power levels, so if you don't have the exact same one, you're going to get different results. So 10% of 300 is 30, 10% of 150 is 15. So,
and I'll add to that the centering of the nozzle on specific materials and specific cuts is detrimental to the process. So did the person set it up the same?
Correct.
Here's another question. As these come in, I'm sorry, I'm reading them live. Does the laser system require its own power drop? And if so, what is the voltage and what is the acceptable variance?
The laser gets its power straight from the machine. The laser is a little more sensitive than the machine as far as fluctuation in the power that we've been seeing. We have a UPS included in the system to kind of watch the power or prevent any interruptions in the power, any abrupt interruptions.
Okay, thank you. Here's another one. How small of material diameter could be effectively cut on an L12? This doesn't specifically say laser. I think this is a machine question. So Mark, go ahead.
Well, I mean, we have customers out there can, we're down to 62,000. So, beyond that, of course, there'd have to be testing and checking. But with our bar loaders and the 7mm channel set, we can easily go down, 1/8 or lower.
And if that question did want to know about the laser, I have worked on a welding 16 thousandths diameter tubing that I was welding together.
Yeah, a lot smaller than 125.
Yeah. Oh yeah.
But that's not from bar stock. So the stability of the bar stock would be the variable you'd have here.
So other gentlemen that are on that are helping, my questions seem to have locked up. So can anybody else see? Is there any new questions?
Someone sent focal length is programmable, but there were also manual adjustments in the head. Please explain. The Gen 1 system, we would set the focus manually with that little adjustment wheel. On the Gen 2 system, that wheel gets set before we put the head in the machine. So the focus is set. And after that, we don't mess with that at all. We just do it from the program. Next one was, is the laser system able to be retrofitted in the field or must occur at MCC? The only issues we've had there is a machine that we haven't done before. If it was the first time we were going to put it on a certain model or a certain generation of the L machine, say, we may want to do it in our shop just so that we have ability to adapt anything that might come in question. If we travel somewhere with the system and we run into a problem, we'd hate to have the machine sitting there in pieces while we're waiting for something to be done. Next question was, how about the possibility of pico or femto second laser heads? Any talk of offering them? We do have our partner developer in this looking at the pico. It would be a completely different laser head. The cost from those is extremely more than the current laser systems cost. I guess the unit itself is very expensive. So it's really in the preliminary stages still for the pico. The femto I have not discussed with them yet. I don't see any others at the moment.
I don't know if you would like to continue with the video or not. Just let me know. Otherwise,
I had it, so I was going to the website to play it from the website there.
If you share your screen.
So I did share. And where are we going there?
So as we say that, can you texture surfaces or control a depth with the laser?
Excuse me. Sorry about that. What was the question, Brian?
Can you texture surfaces or control a depth with the laser?
You can't control the depth. You can control the power, which in effect gives you the depth, but it's not like an end mill controlling the depth to that precision. It will repeat. So once you get the power set, you'll be able to control it from that point of view. The texturing I haven't done myself. I've done marking. You do these texturing. Some of those features that they do on parts that I've seen are very in depth. And whether our laser can do it or would be the most efficient one to do it would be the question. It may take a lot longer because of the type of laser that we're using. Did the video come out, Brian?
I don't see it being shared, so I'm sorry.
Yeah, I don't know why it's not going across. Sorry.
I have some other issues. So as we continue here, we're basically at the end of our seminar. If there's any more questions, actually there is one or two more, Randy, if you want to continue with the questions.
Someone sent in, as soon as the last question was read, pico heads, the volume was lost. All right. All right. So the pico head was, I've been told it's a very expensive unit. It would also require re-engineering the head, a special head for that. And I believe he said it had to be water cooled, which we were trying to stay away from the need of having a chiller involved in the whole situation. So it's still in the early stages as to how and what we can do with that, but it is being looked into.
Okay. Well, thank you, Randy, for your help. Mark, I'm going to send you live that you can end your live event.
Thank you, Brian.
Go ahead.
Okay, so, thank you, Randy, for taking the time to answer our questions. And just want to let everyone know that you can also find us on the following formats. So you have Facebook, Instagram, Twitter, YouTube, LinkedIn, and of course, the World Wide Web.
And before we end the total event, we have not scheduled our next sessions of trainings. We're coming up with a schedule. Maybe there'll be a couple at the end of next week, but the following week, you can look forward to some more live events from us. Until then, if you have a specific topic that you would like covered, either in a training or in a sales review, please let your dealers know. Please let your regional managers know, and we would like to listen to your suggestions. Thank you for your time today, and we hope that you keep safe during this COVID-19 nightmare we're all going through, and hopefully somehow, some way, you can have a good holiday weekend. So thank you for attending.